Writing lines in slope-intercept form for graphing. In this video, we're going to distinguish linear from nonlinear equations and then put linear equations into slope-intercept form by solving them for y. That way we'll be able to read the slope and intercept from the equation and graph the line easily. We're also going to learn to write equations for horizontal and vertical lines. Once we know we have a linear equation, we can put it in slope-intercept form and graph it. So let's see how we can distinguish between linear and nonlinear equations. 2x plus 3y equals 6 is a linear equation because x and y are to the first power. If I have 2x squared plus 3y equals 6, that's not linear because I have a square in the equation. X equals 5y minus 4 is a linear equation. Both x and y are to the first power. But if I take that same equation and put in an absolute value, it's no longer linear. 4y plus 1 equals 7x is linear. X and y are to the first power. But 4 over y plus 1 equals 7x is not linear because y is in a denominator. The x and y can appear in any order on either side of the equal sign. What's important is that they're to the first power. Let's start by graphing our first linear equation, 2x plus 3y equals 6. In order to use the slope and y-intercept to graph, I need to get y alone on one side. The equation needs to be solved for y. To do that, I'll first move the x term over to the other side of the equal sign. So now my equation will say 3y equals negative 2x plus 6. Notice that I cannot combine 6 and negative 2x. They're not like terms, so I just have to write them both. Now to get y alone, I need to divide everything by 3. Now I have y equals negative 2/3 x plus 6 divided by 3 is 2. Now my equation is in slope-intercept form. The slope is negative 2/3 and the intercept is positive 2. The intercept tells me the starting point, or the place where the line goes through the y-axis. It's here at 0, 2. And the slope tells me the rise, negative 2, is going down, and the run, 3, is going over 3. So over 3 and down 2 gives me another point on the line right here. Now I can connect those 2 points and extend the line in both directions, and I have graphed the line 2x plus 3y equals 6. The next linear equation we're going to graph is x equals 5y minus 4. It almost looks like it's in slope-intercept form, but it's not because it's solved for x and not y. Well, let's get y alone. We'll add 4 to each side. So now we have x plus 4 equals 5y. And then to get y alone, we'll divide by 5. 5's cancel out, but I have 2 more fractions on the other side. Y is equal to x over 5. That's the same as 1/5 times x plus 4/5. If I like to look at it in the other direction, I can write y equals 1/5 x plus 4/5, and now I have the slope, 1/5, and the y-intercept, 4/5. I start by finding 4/5 on the y-axis. It's not quite all the way to 1, but almost. Y goes up by 1 every 5 that x goes over. So if I mark that, x goes over 5 and y goes up 1, I'm at this point that's 1 above 4/5. It's 1 4/5. Now I connect those 2 points and extend the line in both directions, and there it is. We've talked about two kinds of lines so far, increasing and decreasing. Because the x-axis often represents time, we want to go forward in time, and so if we think of a little person walking along in that direction, they have to climb uphill for an increasing line, and they walk downhill for a decreasing line. But there's two more things that could happen. The line could be horizontal or flat, so a person isn't walking either uphill or downhill. Or the line could be vertical like a cliff, and a little person would fall off. Suppose the y-axis represents money I have in my wallet, and the x-axis represents hours throughout the day. If I start the day with $5 in my wallet, and I don't spend any money, and I don't get any more money, then that $5 stays unchanged all day. If I imagine what the rate of change of dollars to hours is, well, it hasn't changed at all, no matter how many hours have passed, and so the slope of this line is 0. That makes sense because between increasing lines with positive slope and decreasing lines with negative slope, there must be a line with 0 slope. If I want to write the equation for this line, it starts at the point 5, so the intercept is 5, and the x term is multiplied by the slope, so 0 times x just makes that x term cancel out. We can write the equation of this line as y equal 5. The x term isn't important because it's multiplied by 0, and no matter what x is, y is always 5. It seems strange to have an equation for a line that has only one variable, but the x variable is just understood to keep changing, and the y variable stays constant at 5. It's hard to put any interpretation on this line, especially if you consider the x-axis as time, because this has every possible value of y all at the same time. But x is 6 in each case. Just like we wrote the equation for the previous line as y equal 5, we write the equation for this line as x equals 6. And what's the slope? Well, x hasn't changed at all. There's no run in the rise over run rate. Even though it looks strange to have only one variable in the equation for a line, in this case, x stays constant at 6 and y changes through all possible values.